Okay, good morning everyone. So, we're going to have our lesson on complex numbers today. So I know this might seem a little confusing because the worksheets, like I said on Friday, some of the worksheets that you've been doing already have been involving complex numbers, but you did learn them last year, so technically it is a review. This whole unit is a review. But going through the basics, remember that every complex number has a plus bi. Obviously, the names of b and I, like the denotation of the variable, is not super important, but the I is very important because the I is actually what makes my number complex. So i's, remember, the square root of -1, because the square root of -1 is not a real number, right? There's no two numbers I can multiply together to give me -1, that as long as those two numbers are identical, right? Because +1 squared gives me +1, and -1 squared also gives me +1. So I is not real. So every complex number has two components. Its real component and its imaginary component. Okay? And now, of course, sometimes you're going to get something that's just real or just imaginary because one of these two coefficients could be 0. Okay? So we're going to start off with two simple examples. So example number 1, and after I write down each question, I'll take a little break in the way I speak, so that'll give you a chance to pause the video. And, sorry, I'm just copying the question here. Complex number. So it'll give you a chance to pause the video and try it on your own before you go straight and see my solution. So I've got the square root of -8, and then b will be the square root of I. Okay? So I'll give it a try. Alright, now I can simplify this the same way I did all the way back in grade 9 pre-IB when I learned how to simplify radicals, right? I see something underneath the square root and I break it up into pieces to see what I can get out of it. So what I'm going to break this up into is, number 1, I'm going to get rid of that negative sign. So I'm going to get that -1, which will eventually become my I. And then 8, I don't necessarily need to simplify it right away, but I can see that I can factor out a perfect square factor. Right? I can do times 4 times 2, right? That's what I've broken my -8 into. The -1, because I want that to become my I. The 4, because that's a perfect square, so I can actually eventually move that out of my square root. And then, of course, the 2 I can't really do anything about, but that's fine. It can just remain as part of my radical. So, again, this step that I'm writing now is not necessary. I'm just doing it super clear because I'm teaching. But the square root of -1 becomes my I, and I'm just going to preemptively write it last. My 4, square root of 4, is just going to be 2, and then I'm going to be left with root 2. So 2 root 2I is my final answer. There's nothing to simplify there, and I don't have a real component, so I'm just left with my coefficient of I, which is just 2 root 2, and then my imaginary number. Okay, so for this one, how can I simplify this any further? The way I can simplify it is actually subbing in what I is. So I have, and I'm going to write it extra large, I have the square root of the square root of -1, right? I'm just replacing I with what its definition is. And now, instead of writing it as a radical of a radical, I'm going to get rid of the roots, and I'm going to rewrite this number, but as a power. So it's going to be -1 to the power of, and remember, when you rewrite a radical as an exponent, the index of the root, which isn't written here because it's a square root, but it's implied to be a 2, becomes the denominator of my power, and then the exponent that I currently have, which again is not written, but it's implied to be 1, becomes the numerator of my radical. So it's -1 to the power of a half. That takes care of the first root, but then I've got a second one. So that whole thing is also to the power of, 1/2. I almost skipped to the final answer there. So 1 second here. Let me white that out so it's nice and neat. Okay, and now when I have a power of a power, I just need to multiply these two exponents. So I still end up with -1, but now a half times a half is just going to give me a fourth, and I'm done. Okay, so I've simplified as much as I can. Alright, so moving on to the next example, I'm going to break our lesson, by the way, up into smaller videos because, number one, it's easier for you to digest basically when it's not one long 30 or 40 minute video, and also I am pretty sure, because I don't have a paid account on YouTube, that I can't upload anything that long. It has given me trouble in the past. So for example 2, before we actually get into the question itself, we need to write two things. The first thing is just keeping in mind that, that we can express complex numbers in two forms, rectangular form and polar form. We're not going to be touching polar form yet. We're going to be doing that later in the course after we finish trigonometry. But rectangular form is what I wrote above. So it's a plus bi. Right? My real component, my imaginary component. And the other thing I need to keep in mind about complex numbers is that each complex number has a conjugate. Right? If my first number is a plus bi, my second complex number, that would be the conjugate of the first one, would just be a minus bi. And the reason that's important is because z, so our imaginary number, multiplied by its conjugate, which can be denoted as z with a little star on top, so z with a little star on top, or z with a bar above its head, will just be equal to the absolute value and then squared. So I was going to say the absolute value of z squared, but the square, the exponent is on the outside. Okay, so the reason why this is important is because sometimes we'll need to use this rule to simplify. So again, I'm going to write two examples. I'll take a brief pause so you can pause the video and try it, and then we'll take it up together. So simplify. I've got part A is 3i minus 7 plus 2 bracket 6 minus 2i plus 3i. Okay, so similar to the way you would do this all the way back in, I'm pretty sure even before grade 9, we just have terms that are only constants, so in other words they have no variable attached to them, and now we still have numbers that don't have variables attached to them, but we have I attached to them, so they're not groupable. Imaginary numbers and real numbers are not groupable. So that's what we need to do. I'm going to open up the bracket first, so 3i remains unchanged, negative 7 remains unchanged. Here it becomes plus 12 minus 4i plus 3i, and now all I have to do is group my 3, negative 4, and 3 together, and my negative 7 and positive 12. So I'm going to do the real part of my of my complex number first. So negative 7 plus 12 would give me positive 5, and then 3 plus 3 gives me 6, minus 4 gives me 2, so I have plus 2i. And like I said, this is my final answer because they are not groupable. Okay? Now, for part B, I've got this. I've got 3 plus 2i divided by 5 plus I. And now we need to simplify this as much as we can. So I'm going to take a brief pause so you can pause the video and try it for yourself, and then we'll take it up. Okay, let's do it. So that's why I wrote these two next to each other, because here I have a complex number in the bottom, but I can essentially get rid of it. So the same way in grade 9 and 10, when you're supposed to simplify a radical because the square root is not acceptable in the denominator, here we can simplify by actually getting rid of the complex number in the denominator. It might make our numerator more complicated, but that's okay. So what we're going to do here is multiply by the conjugate. So I've got 5 plus I in the bottom, so that means I'm going to have to multiply by 5 minus I on both the top and bottom. Okay? Of course, I have to do it on the top and bottom, or else I'm changing the value of the expression, and then obviously I can't do that. So now I just need to multiply everything out. My denominator actually becomes really simple, right? 5 times 5 just gives me 25, so 5 squared. And then minus, what do I have? I have I squared. So remember all the way, oh, I don't think I wrote this, but it's fine, we can do it in our heads. We have the square root of -1 squared. And the square root and the square just simplify. So for the time being, I'll leave it like this because we have multiple steps left anyway. And then my numerator just becomes 3 plus 2i, 5 minus I, which we'll have to expand to simplify. So my next line of my equation. What do I have? 25 minus -1. So careful, this is the only part where you can really go wrong in the denominator. This does not become positive because that's the whole identity of it being an imaginary number, right? I've got minus -1. And then here, I just need to FOIL. So 3 times 5 gives me 15. 3 times -I gives me minus 3i. Positive 2i times 5 plus 10i. And then here, I've got minus 2 and then I squared. So let's see if we can simplify this. The 15 has nothing to group up with yet. These two can be grouped together for positive 7i. And then here, -2 and then I squared. Remember, -2i squared is just -1. So this will actually become a real number, and it will be able to be grouped with my 15. Oh, sorry, I said 15, so I was going to write it in the denominator too. But 25 minus -1 would give me 26. And now I'm almost done. I just need to group 15 with positive 2 now, so this becomes 17 plus 7i all over 26. And just because I want to make it super clear, I don't want to write them together, I want to write them in rectangular form, I'm going to write it as 17 over 26 for the real component plus 7i over 26 for the imaginary component of my complex number. And then that is the end of that example. Okay, so I'm going to stop the video here. Just go on to the next video in the playlist for the next part of this lesson.